Guys, the plan was that I would present together with Alyssa Shevchenko. Unfortunately, it didn't work out. And we are going to upload our work together later on. So I'm going to tell you about system analysis of Java zero-day exploit. Okay, Java threads. Well, you must have heard about yet another Java vulnerability being discovered, and in fact, there is even a website called javazeroday.com where people actually tell you how many days have passed since the last zero-day exploit, and this is not obviously a vulnerability found by detectives. This is an exploit, this is a problem found by the baddies. And the longest time was 46 days. What you see here is statistics on usage of exploits in different exploit packs. Until 2012, Flash and Adobe Reader vulnerabilities were very popular. However, recently Java vulnerabilities have risen in number. And you will see that Phoenix was the first to start using Java vulnerabilities. In my presentation, I'm going to use some key terms that will be useful, such as this. Essentially, in security aspects, we shall be talking about, for example, language execution, where we check for types, for example. And we will do bytecode verification. Next, we shall look at access controls, such as accessing private classes. If you've done Java vulnerabilities, you must have heard about security manager function, and this is a function that can be switched on or switched off. Finally, we shall talk about code signatures. In corporate applications, such as those used by banks, you sometimes need to request this or that system function, and in that case you will need to sign your own code. Oh, in fact, sometimes you will see Java applets that are signed by Oracle. Okay, we'll look now at different access levels. So if you've done programming and then you know OOP, and this is how essentially access levels are stratified. We have private, protected, public, and package. And to make it clear for you, we've shown a table below. Now let's look at the bytecode verifications. So the first thing you would like to see is whether you have a match in terms of language specs. Secondly, you will want to double check whether there are any namespace violations, whether it addresses any memory elements that are already owned by other programs, for example. Next, you would like to check for stack overflows or time confusions or invalid data type transformations. Let's look at security manager policy. Essentially, it's based on several security aspects. First, we shall look at policies. It must have happened to you that you would run somebody's Java applet, and you will be asked whether you would like to use this ActiveX extension or not. And this is what the Internet Explorer would like to ask you. So there are three levels of security policies: server level, applet level, and application level. In fact, they are all kept in the same folder called lib/security. Let's look at security manager class loader. This is the actually uploads classes. And we know that Java is a language with a delayed code loading, which means that first our applet is going to be loaded up with the system loader, and then we shall upload the classes using and leveraging, in fact, different loaders depending on the class. Okay, next we have namespace. You will see here the standard vanilla class loader. And this picture shows how we will load the same classes from different applets. Because we have this distinction between different class types, actually this gives rise to a range of different security issues. In fact, several exploits targeted directly. Well, I think you understand the numbering sequence starting from version 10. They actually have this notification that will tell you you gotta update. This is besides the main window that's located next to the clock if you're using Windows PCs. Say your applet or your application is requesting access to the system but doesn't have certificates, or the certificate is over. You must have heard about this attack when certificates would be stolen and then they would be used to sign different Java applets. Reflection. This is essentially a mechanism of data research of data on the program as it is being executed. For example, we're uploading here a class using its name. I assume that if you've written any programs, for example in Java, you must have imported classes. Instead of such an import, you can use this particular structure. This is how you address a class using string variables, line variables, I'm sorry. It's a string variable, right? Ser-deser. Serialization of deserialization. I'm sorry if it sounds slightly scientific, but you do understand what that stands for. In very simple layman terms, we take all Java data, save it to a file, and then we can extract this data from such a file. Well, in the latest vulnerabilities, it was actually used to bypass the window I showed in the previous slide. The way it works is that we save our application to, say, a file. We call it whatever, a gray box. Then we restore it, deserialize it from there, and Security Manager doesn't notice that, or doesn't react to that. Well, in order to leverage Java exploits, you will need a certain environment. I'm going to show you some key things here, but please remember that in the future, we are going to run a workshop in our space in Moscow. So we're going to use a vulnerable JDK. The JDKs, as such, are not really updated. Well, you just download the ones you need, and then you connect them to the primary code. So we're going to use Eclipse 4.2, which is a very popular environment. In fact, for a very long time, it hasn't had any real competition until recently. Also, to make it a more realistic environment, we're going to use several plugins. One is going to be a decompiler, another is going to be used to represent Java bytecodes. If you have any problems with decompilers, we suggest you use just a standalone decompiler. Okay, so we're going to use also DDG or JAT, and in my previous workshop last year I said why use two. They decompile differently. JDG has a very user-friendly interface, but it sometimes misdecompiles bytecode. However, JAT is console-based. I'm sorry, JAT does a much better job of it, but it's only console-based. So you're using a standalone decompiler. You know already the pluses and minuses of two different solutions. But you can actually use decompiler plugins. This is how you add additional software. You can choose which decompiler to use, your specific piece of software. And this is a plugin that helps you address the bytecode of Java. Well, a problem you can run into Eclipse was that you need to separately connect GREs manually. Actually, this is what it looks like in the interface. So for the TGR class, we simply need to connect our source.zip, which is stored in JDK. The most important thing here is that in order for your exploits to work well, you need to switch on your security manager, because by default everything you run off a local machine does not trigger, so to speak, the security manager. You need to switch it on manually. In order to recreate the environment of a real-life machine for the Java applet, you will need to copy a file of a Java policy into the project folder. Then for decompiling and debug, I will choose this particular payload here. I will indicate which parameters I would like this Java applet to run with. What many people forget usually is that we can actually switch on the Java console. It is switched on in Windows through the control panel. On Linux and Mac, you need the command line to fire it up. You can actually launch it via browser, but I think it's much easier to do it through the control panel. So you'll see here that Java applet works just fine. If you're slightly paranoid, you can actually switch on the console on your machine, and then you will see whether there have been any exceptions, any crashes with Java. That way you will be able to guess if somebody is trying to attack you by exploiting a Java vulnerability. Well, you must know this website, certainly. They give you many lists of vulnerabilities, or the list of many vulnerabilities. Well, over time they learn not to say steal from each other, but please remember that if we are talking about some recent exploits, there will be serious differences between them. In fact, Open GDK is probably the best way to get essentially samples of Java source code. But then Bugzilla from Red Hat can actually show you the latest patch. That way you will learn what they've added and which particular vulnerabilities they've addressed. For the purposes of this analysis, we looked at exploit 2013-0422, or rather this particular vulnerability. Well, you certainly know that it's a real war out there. Bad guys develop their exploits, and Metasploit updates their module. Or it can be the other way around. Researchers first update their exploits or develop patches. So it is first Metasploit and then baddies, or the other way around. In this case, you see that it starts in 2013, although this vulnerability was first detected in mid-December 2012. If I'm not mistaken, it was first published by Coffee, and I think Blackhole and several others use this vulnerability first. And then some very nice researchers called Damage Lab, they actually show the source code of this exploit with the tagline "From Russia with Love." So after it became available, a module for Metasploit was soon released, and now we can show you the first video that shows how you can compile and demonstrate a specific exploit you've learned about on the net. Video time. And by the way, all demos and presentations are going to be uploaded to the server, so you shouldn't be concerned if you miss out on something. Okay, it seems to be working. So we connect the .java files. So we create a project, we give it a name, and then we identify or we enter the bin. I'm sorry, we indicate where the file should be created, essentially, using the bin command. Sometimes when you decompile sources, you can essentially run into errors, so you will need to use your Java programming skills in order to bypass or eliminate these errors. Or you can try using several different decompilers to arrive at something functional. Okay, so I'm trying to show here that Security Manager is now up and running. Here we are showing where you can find Java security policies, and we are copying this particular file into the .bin folder we have created for the output of our file. It's actually called Java policy, very handy name. Next we rename it into .applet, because I have told you already that for applets policy is different. So although we are going to type here java.policy, it's actually going to be created, this file is going to be created as java.applet. Well, if you don't reconfigure it, it's going to assign you all the rights. Well, I'm setting up all the backpoints here so that it will be easier for us during the debugging session. Well, now we know what this vulnerability is about, but one day you might be analyzing some zero-day vulnerabilities, so this will come even more useful. So we set up our own configuration for the debug operation. If you use the right window here, you're going to see your own executable configuration. So this is the standard window here. And you will see here it says that Security Manager is up and running. So here we are addressing public class through JNX server, and by doing that we can actually refer to restricted classes. And by doing that, and by employing reflection at the same time, that is by using the method name, we can actually address the system class or the class that can switch on or switch off the Security Manager. Here in the window for local variables, you can see what kind of variables are uploaded. If we're doing a reflection, for example, this way you will find it easier to see what kind of functions are actually being tagged there in this particular vulnerability, and then find them elsewhere. And you'll see here this S loader is being used for the last element of reflection, and in order to switch off the Security Manager. So it has been uploaded, then we launch the class. And payload is a separate class, obviously. It comes with a payload of its own. So then it launches an exe file, which is embedded in the source. And it also has a functionality to carry on a backdoor. And you will see in the end that Security Manager equals 0, which means that the exploit has been fully successful.
Let's now proceed to the next video. I'm going to quickly show you how we're going to connect the exploit. For instance, Imagine you have a machine which had an incident, and you're studying some vulnerabilities or issues with security. Thus we create an empty project, quickly showing how we do it, and we show the path to the job. Actually, being a source folder was created here manually. The job file is inside. Right here, we connect it, unless it's there by default. And our decompiler will be connecting all the classes. Thus, our decompilers will be shown here on the screen. Right here, open bytecode analyzer, just like previously you are downloading the same chart. Why we need that? Because you can always cope with that, so it's easier for you to do it at the bytecode level. And you can decompile everything in the same folder, the source folder. Why we do that? For breakpoints at lines to get local variables. If you just simply use the job file, you won't be able to do that. One of the examples is the security manager activation. And you'll have to find the applet class. Then in the configure manager, you show the name of the class. And right now I'll just come up with a quick example of a variable.
Вот, я поставил сразу breakpoint, сработал, и мы видим всю нашу переменную, которая была получена из файла с таким странным расширением, и плюс она была зашифрована по...
The entire variable is here. We use the garbage variables all across the board. You may use B64, XAR, whatever. If you did not have source files, you can automatically check the classes in your Eclipse folder. That would be enough just to enter the first letter. So we're done with the second video. And the third video has shown what exactly is happening when we launch the exploit, the patched machine, with the 721 update on it. It's just the same thing that we used in the first video. We forbid the use of that particular cluster. You might have seen that that exploit was caused in triad cache. So the exploit does not turn out to be operational here, doesn't work here. In the first video, I was telling you about the problems that might occur. There are some classes forbidden. For example, I wanted to compile that, and the compiler automatically stipulates these classes as bad classes. So, in order to compile the exploit on a machine, you'll have to put it in a simple wording, ordinary wording, in a standard settings window. Forbidden references. Thus you can compile it without any major issues. We need the exploit to run In other words, so that they don't even know that the exploit is running. And you can do the antivirus signature for that. What I've achieved proves that antiviruses or Java applets upload the text file from the archive, and you can open these text files with Notepad. You can see the variables, our vulnerability 2013 JNX Bean server related, written simple strings and lines. To detect standard exploits, you just need to maintain regular expressions. I assume that some of the antivirus software decompile those files. It's just an assumption. So what can we do here? The standard method that everyone has done is the change of the variables by a function of other classes. Then you manipulate with the strings. For example, there was a garbage file with the number of symbols, and with the replace command it was replaced. Then we can use other methods. For example, changing the names. It was identified right here, 2013-24-23. The first class we detect, and we detect it until 0. Then we manipulate with strings. You might have seen the JavaScripts when we would take the string and connect it with pluses. But when compiling, Java combines it in one, so it doesn't really work. So we do not just simply split it into different blocks, but we do that separate variables. Or, for instance, we can use the embedded functions, replace, for instance, and encryption. Some alternative methods. Base 64 is the standard method, of course, but to connect it you need a separate library that will increase your exploit size by a few hundred kilobytes, which is not nice. But if we just simply change the string, we change the detect from 5 to 3. Fresh vulnerabilities are here, so the detect is small. Code smearing, when the strings are mixed up. We just simply swap some lines, maintaining the exploit. We'll be able to change the detect, or put some parts of the code as separate functions and classes, and put them in separate files. So we just simply remove it from the very end of the file till the very beginning, and we have convinced another antivirus with that. The specifics of the language. Yet it increases your exploit. We had a simple fine static set. We increase it by 5 strings, but we see the detection is equal 0. It's pretty straightforward and simple, so you can turn the fresh exploit into a new one.
Далее, конструктор эксплойта.
which is concerned as far as the exploit constructor.
Самый популярный, конечно,
Exploit constructor, the most popular one is the Metasploit, Convess, and others. Those that are free of charge and paid versions. You might have made good use of those. Then homegrown scripts. We take Metasploits and our own software there. Specialized ones with wider functionality, adding our own encryptions. You may do it for binary files. The homegrown scripts use Ruby, and you can use it for Metasploit. Sometimes they use Perl or Python. There's nothing difficult here. They're just wrappings for Java, so there are no significant problems with that. Yet there are some other constructors. I call them the high-level constructors. Some of you might like to create the cross-platform ones. For these 0422 exploit, I saw it Java-based for the first time. I don't know who it did it for. Maybe for some authorities. I don't know. That's all basically. I wanted to tell you. Thank you very much for joining us here.
Если какие-то вопросы возникнут, подходите или...
You may come up to me with questions. We still have a few more minutes. You might want to ask me a few questions if you like.
Ну, да, конечно.
Что, когда, можно поподробнее, когда, что?
Ну, примерно, наверное, в июле. То есть, ну, многие из присутствующих знают наш Hackspace. Мы на многих конференциях были. И на базе Hackspace будет проведен воркшоп.
We will have a workshop in July.
Ну, как сказать, может, да, у меня Twitter, я там присутствую.
Please follow me on Twitter and the Hackspace website. We'll be keeping you posted there. Thank you.
Все, всем спасибо.